Hello everyone, let's take a look at our next problem. A steady wind blows a kite due west. The kite's height above ground from horizontal position x equals 0 to x equal 80 is given by y equals 150 minus 1 over 40 x minus 50 squared. Find the distance traveled by the kite. Okay, so this is, we have a function of x between 2 points, and essentially this means, this translates to finding the arc length of the curve given by this function between two values of x. So let's draw a little sketch first of what's going on. So I'm not going to worry too much about the scale of things here, but the equation of the curve given is the following. So we know that it's a parabola, we know it opens downwards, and it's centered at x is equal to 50. Yeah, so we just need to compute the length of this arc for values of x between 0 and 80. Okay, so the formula for arc length, if I remember correctly, is given by this. So let's compute this derivative. Y is equal to 150 minus 1 over 40 x minus 50 squared. So y prime. Okay, so I've reduced it down to the integral we're actually required to compute. I'm not sure off the top of my head what the best way to do this is. It looks like maybe there's a trig substitution to be made. Well, let's do a little bit of simplification first here. So integrating the square root of u squared plus 1. I'm going to start taking some, that should be a du. Okay, so I'm going to play around with some substitutions and see if I can figure out what this should be. But it looks like something trigonometric. Okay, so I think I've done this correctly. Make sure that this is the right identity here for a second. Sure, okay. So the square root becomes secant y. du is secant squared. So I'm integrating secant cubed now. I've done this before, not too long ago. In fact, I wonder if I'm running in circles here now. If I the method of integrating secant cubed, doesn't it pass through this? Let's find out. Let me try and find out how to integrate secant cubed again. I don't remember what I'd done last time. Okay, so I've derived the antiderivative of secant cubed again here. Kind of forget why we needed that exactly. Okay, so we needed the length of our arc is going to be computed by evaluating this thing at these two endpoints. Goodness, okay. So L is equal to 20 times the integral from tan inverse of negative 2.5 to tan inverse of 1.5 of secant cubed y dy. Is it worth actually doing this substitution? I don't really think so. I mean, the answer's mostly complete here, right? The rest is just subbing in, subbing these endpoints into the antiderivative there, taking the difference. And I don't think there's going to be any kind of nice simplification or anything like that, given these endpoints. Maybe a little bit of care needs to be taken in handling this. I don't really think so. Right, there's no, we're integrating across 0, but I don't think this thing becomes, does it change sign? I mean, another thing to do here, in order to make things kind of nice and consistent and not have to worry about signs and stuff like that, it might be a good idea to integrate along one side of the curve, and then we know that's just going to double, but then there's going to be a little bit of leftover component here. I don't really see any problem. Yeah, this should be fine. With these substitutions, take the difference, and it'll be some number. But if I have any follow-up comments or think of any mistakes I may have made, check the description. Thanks for watching.